Hello everyone, welcome to my channel. Today I'll be doing question 12 of the Edexcel GCSE Paper 1 Higher Tier, June 2018. Okay, before we get started though, just make sure you're subscribed, just like my friend over there in the corner. Okay, now let's get to it. Question says, prove that the square of an odd number is always one more than a multiple of 4. Okay, how I like to go about these questions is I like to actually get numbers, right? Real examples to actually see what's going on, right? So it says we've got an odd number. Let's just say we've got 3, right? And then it says we need to square it. 3 squared equals 9. And then apparently this is one more than a multiple of 4. Well, this is the same as 8 plus 1, isn't it? And 8 is a multiple of 4. It is 4 times 2. Yeah? Let's get another example. Let's say 5, right? Another odd number. We square 5, we get 25. This is the same as 24 plus 1. And 24 is a multiple of 4 because it is 4 times 6, right? So just a quick note, a multiple of 4 is a number that has a factor of 4 in it, isn't it, right? Cool. So this pattern here that we've seen, obviously we've done it for only 2 cases, right? But in maths, you cannot prove something with just examples, right? You need to prove it for all cases, right? As there is an infinite amount of odd numbers that you could choose from, right? You can't just go about doing all the odd numbers, right? You can't. So this is where the algebra comes in, right? So the pattern we've just seen, we need to express it in an algebraic sense, right? In an algebraic manner, right? So what we need to do, we need to get a number, right? Which we know is odd, square it, and then see what happens, right? See what the expression looks like, right? How do we go about doing that? Okay, so we need to express an odd number algebraically, right? So if I just give you a quick number line, so let's just say we've got 1, we've got 2, we've got 3, we've got 4, we've got 5, we've got 6, right? The odd numbers here are 1, 3, and 5, right? So just a quick one, as you can see, yeah? If I wanted 3, right? You can see clearly that either side of 3, there are 2 even numbers, isn't it, right? So I could say that 3 is the same as, well, going 1 up from 2, so 2 plus 1. Or I could say 3 is the same as going 1 down from 4, 4 minus 1, right? And you can see the 2 and the 4 are both even numbers. Yeah, so therefore you can see that an odd number is just an even number plus or minus 1, isn't it? Right? Clearly. Yeah. So how can we express that though with letters, right? Okay, let's just say I have the letter N. So let's just say I have the letter N, right? This is any number, right? This is not enough to say that this is an odd number. It could be anything. It could be even, it could be odd, it could be whatever. Right? However, what I could do is if I multiply n by 2, right? This is most definitely an even number. Why? Because it has a factor of 2 in it. The number is 2n, and that means 2 multiplied by n, right? Every even number has a factor of 2 in it, right? And as you can clearly see, an odd number is just an even number plus or minus 1. So therefore, I could just say an odd number, I'm just going to write NO for short, equals, and I'm going to write E for even, E plus or minus 1, right? And then since we know our even number is 2n, this is the same as saying an odd number, right, has 2 forms. You could either write 2n plus 1 or 2n minus 1, right? Okay, so that's that. We've got our algebraic odd number, right? So what we need to do now is do the exact same thing we did for 3 and for 5, right? So we need to square it now. Okay, so what I'm going to do, I'm just going to put 2n, right, plus 1, right, squared, right? Or I could do 2n minus 1, right? These are both odd numbers, so it doesn't matter which one you choose to go with, to what you choose to work with, right? I'm going to choose the first one, yeah? So if I have 2n plus 1, right, and I square it, this becomes 2n multiplied, 2n plus 1 multiplied by itself, isn't it, right? So it'll be 2n plus 1 twice, like that. And then now you just need to expand the brackets, don't you? So I'm just going to do it underneath here. So the first term, 2n times 2n will give me 4n squared, right? 2n times 1 will give me 2n. 1 times 2n will give me another 2n. And then 1 times 1 is just 1, isn't it, right? This simplifies to 4n squared plus 4n, right, plus 1, right? And this is our odd number still, right? We started with our odd number, we squared it, and now we've got this result. So what I'm going to do, just going to get some space down here. Okay, so let me just write that again. So we have our odd number, right? We now know it's 4n squared plus 4n plus 1, right? And then according to the question, this is apparently always one more than a multiple of 4. Okay, we can see that there's 4s around all over the place, so which is a good sign. But how can you show to the examiner that this is clearly always one more than a multiple of 4? Well, what you can do is if you look at it, right, you've got 2 terms and then a plus 1 at the end, right? So you can definitely say, well, it's one more than something, right? But what is that something? So here, what I'm going to do, I'm going to put a square bracket around the first 2 terms, right? I'm just grouping them in a way that you can see it clearly. It doesn't do anything to the expression, right? So it's something plus 1. In other words, it's one more than something, right? Okay, now if I look at this expression in the bracket, right, I can clearly see that there's a common factor of 4 in both terms, right? So we can factorize. So here, if I factor out of 4, I'm going to get an n squared plus n inside plus 1, right? And remember what I said at the very beginning. Something that is a multiple of 4 will have 4 as one of its factors, right? So can you see here, this expression here, this is a number. It's 4 multiplied by n squared plus n, right? This here is one expression, right? It's a number. This number clearly has a 4 in it, right? So therefore here, this is definitely a multiple of 4, right? And then obviously there was just a plus 1 at the end. So you could just say to finish off, therefore it is always one more than a multiple of 4. And you're finished.